Today we are going to talk about scatter plots. A scatter plot is a graph of plotted points that shows the relationship between two different sets of data. We don't connect the dots like we've been doing in the past to make lines. What we do is we look at these dots and we look to see if there are any patterns or trends among the dots or the points. So for instance, if you look at the graph on the left-hand side, it looks like the majority of the dots are kind of moving around this general direction. They're moving upward. If we look at it in terms of what this graph means, somebody's grade, as the grade is getting higher and higher here, the number of minutes studying is also increasing. So as the X value is increasing, the Y value is increasing. That's a pattern that we could notice from this graph. What we also want to do is look for points that lie outside of the general trend. Those are called outliers. In real life, graphs aren't always perfect, and we don't have all the dots just lining straight up in a line. So there are some things that maybe don't fit the general trend. This right here, the dot that I just circled, could be an example of an outlier. It's far away from the main group of data. This person got 100%, but they only studied for about 10 minutes. That's usually not the case. Usually the more you study, the higher your grade. Another example of an outlier can be seen looking at this graph down here. This one dot is farther away from the main trend of dots moving upward. If you have a whole group of dots together on a graph, that is called a cluster. That's when several dots are just gathered around one particular value. So let's take some time and let's look at some of the patterns that can happen when we analyze a scatter plot. In my first example, it says Susie went to the mall and surveyed shoppers to see how many items they'd purchased and the total amount of money that they'd spent at the mall. She created the scatter plot. The first question says, how many shoppers did Susie survey? So how do we find that information? Well, if you look at the graph, what you would do is you would count up all the different dots there. And so the number of people that she surveyed is 16 because there are 16 different dots on the graph. Now what we want to do is we want to look and see, is there any kind of a trend? Does the number of items purchased seem to have an effect on the amount of money that a shopper spent? So you can see here, there is sort of a general trend. Most of the dots are grouped together here along the middle. And it looks like if we would draw a line through those dots, it looks like the general trend is that it's moving upward. There's a positive slope to that. So if we look at how the number of items affects the total amount of money spent, as each item, as you purchase an item, like one item would be maybe $40, two items averages around 50, three items average around 80, and so on. It looks like the pattern is that the number of items, as it increases, the total amount of money spent also increases. So that could be a pattern that we could get from this graph. There are a few outliers, a few points that kind of lie away from everything else. So let's take a look at that. Again, the general pattern was these were all kind of the main group of dots, but I have a few that are lying outside, like maybe this one up here, maybe even this one down here. If we look at this one at the top, the person bought about 3 items, but they spent $140 if you analyze this dot right here. Normally, that's like a little bit higher than what the normal average was compared to all the other dots in the graph. So that's one way we can analyze that graph. Let's look at another situation. This situation here for this scatter plot compares the number of hours to the number of miles that somebody is driving. If we try to find a general pattern, most of the dots lie around this range that I'm circling right here. There's an upward trend. If we kind of think of a line going through that, the slope of that line is positive. So what we say when we see an upward trend to a scatter plot is we say that it has a positive correlation. Again, positive correlation, where the trend is upward as X is increasing, as my number of hours is getting bigger and bigger here along this X-axis. The number of miles that are driving is also increasing. So think about that. If you drive 2 hours, you're going about 50 miles. According to this graph, in about 3 hours, you're going about 75. The miles is going up as the hours is going up. That is a positive correlation. We do have a few outliers in this graph, just to take a look at them. This dot here is an outlier, and this dot up here is an outlier. This one at the bottom right here shows that somebody drove for 5 hours and drove only 75 miles. So think about what that meant. They probably were going a little bit slower than everybody else. This dot up here at the top, somebody drove about a little over 3 hours, and they went about 150 miles. So they probably went a little bit faster than everybody else. So that's one way we could analyze that graph. Again, that graph has a positive correlation because it has a general upward trend to the dots. Looking at this next graph, the general trend for these dots looks like they're going downward from left to right. So if I were to put a line through that trend, that would be a negative slope. When that happens, we say that the general pattern to our scatter plot is a negative correlation. As the X values are increasing, or the time spent shopping is getting bigger, the amount of money in the wallet is going down or getting smaller. That again is called a negative correlation. So think about it. As you're spending more and more time shopping, the amount of money in your wallet's going down because you're probably buying things. Is that always the case? No, in real life that's not always the case. So we have these outliers that don't lie in the general trend. And that's okay, because that's real life. Some people, like this person here, spent only 3 hours shopping and yet they had 0 money left in their wallet, whereas this person right here spent 6 hours shopping and still had money left compared to the other people. Again, a downward trend, a negative slope, is called a negative correlation, where as X is increasing, Y is decreasing. The last thing I want to talk to you about is what happens if there is no trend. Notice for this scatter plot, the dots are scattered all around. That is called no correlation, when there really isn't any connection between the two sets of data. This data talks about points a team scored compared to how long you're cheering for them. Does it matter how long you cheer for them to determine how many points your team is going to score? No, they really don't relate at all. The one does not affect the other. So that is called no correlation. There is no pattern, no upward trend or downward trend. The points are just scattered all around. So let's apply that just a little bit here. At the bottom, I've got examples of a positive association, negative, and no association, and what the graphs would look like. Let's talk about 3 examples and see which of the 3 categories these would fall in. So first of all, letter A says, the hours a person studies and the number of states they visited. So how do you think those compare to each other? Is one increasing while the other is increasing? Is one decreasing while the other is decreasing? Or do they really not relate to each other at all? Do you think the number of hours that a person is studying is going to increase the number of states they're visiting? Or will it decrease the number of states they're visiting? Or does it not even relate? Well, if you said that there's no association, then you are right. The number of hours a person studies has no effect on how many states they visit. They could study not at all and visit 50 states, or they could study hours and hours and visit no states. It really doesn't matter. Now let's look at letter B. Letter B says the hours a person studies and their grade on an exam. So let's think about if this was a positive association. Do you think that as the number of hours a person studies increases, their grade on an exam will increase? If so, that would be positive. Or do you think if the number of hours a person studies increases, their grade will decrease? If so, that would be negative. Well, if you said positive, then you are right. as the number of hours that a person is spending studying goes up, their grade on the exam is going to go up. It's going to increase. So that is a positive association. The last example says the hours a person studies compared to how much time they spend watching TV. So if you think about that, if this x-axis is the number of hours that a person is studying, then if they don't study very much at all, they're probably having a high number of hours of watching TV. But if they study a whole bunch, as that number of hours is increasing, the number of hours watching TV is probably going down. So this one here would be a negative association. So those are some examples of scatter plots and their trends and how we analyze them and their outliers.